Hey all, welcome back to Text to Action series where we transform natural plain language into real world actionable outcomes by building intelligent systems using AI. In this third part, we're going to see how we can convert a natural plain language to calendar events by building a smart AI assistant. Before we dive deep into the code, let's have a quick look at the final outcome of this specific project. I'm currently running the application at port 3000 and in this route, voice commands. And this is the UI, very simple UI. The first thing we have to do is to authenticate with Google. So once it's done, we are good to go. As a user, all you'd have to do is press and hold the microphone while speaking and release it when we are done. And this will create calendar event automatically here. So just in case, to refresh, I have no calendar event right now in May 2025. So let's go back to the voice commands page and start scheduling event via speech. Schedule a team meeting tomorrow at 12 p.m. for 30 minutes.
Event created successfully. Team meeting on May 21st, 2025 at 12 o'clock p.m.
Cool. So we did create it as expected, no issues. So let's try one more just to make sure it's working as expected. Create a dentist appointment next.
Event created successfully. Dentist appointment on May 20th, 2025 at 9 a.m.
Okay, it did create it, but I haven't finished yet. But let's me try it one more time. Create a dentist appointment next Friday from 2 p.m. to 3 p.m.
Event created successfully. Dentist appointment on May 22nd, 2025 at 2 o'clock p.m.
Cool. It did work as expected. Just want to call out that there are some edge cases that we need to handle in this specific flow, but it's completing the objective that we would want. Just to give a quick recap, in part one, we have established our foundation by creating an Express.js backend that connects to the Google Calendar's API. This exposes an API endpoint, which gives us the ability to pass required JSON payload and create event successfully. For example, I'm exposing in the first part the /API/create event where you pass this required JSON payload and creates the event successfully. Now in part two, we have added a natural language processing capabilities by using Ollama that I'm running locally to convert this natural text word and generate that JSON payload and reuse the part one endpoint to complete creating the calendar event. Specifically in here, if you in part two, if you scroll down to step number 5, you could see that we are exposing in another endpoint called as text to event, where we can pass natural plain text, which gets converted automatically. Now in part 3, we're going to reuse what we have built in part 2, except now we are going to transcribe the speech to text and then reuse the infra that we have built in part 2. So let's get started. So the voice to action flow pretty much looks like this in a high level overview. We start with the user command, which is with the natural voice, and we convert that speech to text using Web Speech API, which is then sent to the NLP for processing. And then using a LLM, we convert that to a structured JSON payload, and then we call the Google Calendar API, finally creating the Google Calendar event. There is also a voice feedback feature where it's going to give us a feedback after the event is being created successfully. Cool. Let's dive deep into the project architecture and have a quick code implementation walkthrough. The entire code is available in this repository, so please feel free to dig deeper into it. There is also a dedicated sections where it go over how to set up and what's there in detail. Now, in terms of project architecture, we have 3 core phases here. One is backend, which is the Express.js, which handles the API requests and connects to the Google Calendar and its API. We have NLP processing. We use Olama to understand natural language and convert that to proper structured JSON. And then we have front end, which is this one over here, where we see and test the the features in the UI. Let's have a quick code implementation walkthrough to understand how exactly this functions end to end. Firstly, we create the press and hold interface, which represents the similar Google Assistant interface, where we simply press a button, speak, and release it to see the completed action based on the speech instead of a simple toggle button. So in the code, we have mic button, which is the DOM element ID to identify this specific DOM element. Whenever the user presses the mic button, we start executing the start listening function. And when the user releases the mouse button, we execute the stop listening function. Similarly, we achieve the same thing in the mobile browser using touch start and touch end. When the start listening function is being executed, if there are no other listening happening, then we would reset the transcripts. Final transcript refers to the confirmed high confidence speech text, while interim transcript is a real-time tentative speech text that is not yet completed. So now we start the speech recognition workflow by calling the recognition.start, and then we would update the listening to be true because we started listening, and we add a few visual changes in the UI mentioning that we have started listening to the speech. And then in stop listening, we're going to stop the recognition, and then we're going to set listening to false. And then similarly in the UI, we'll say that it's been processing. Cool. Now let's head back to the core functionality by understanding Web Speech API. So Web Speech API is the one that we use here to help us to incorporate voice data into our web app. It comes with two parts: speech synthesis, which is text to speech, and then speech recognition, which is an asynchronous speech recognition feature to convert the speech to text. So this is the one that is very important. The speech synthesis is just a voice playback that we add as a nice to have, so that we can understand what happened by the end. The speech recognition function execution flow has three different phases. In the success phase, first the recognition.onStart is being executed, then the on result where the actual speech to text process happens, and then finally on the on end, once that is being completed, we'll be able to access that specific information there. That's where we'll be able to retrieve the final transcribed text information. And we will be able to call appropriate endpoints to process those converted text. Similarly, in the failure, we would use the on error, where if there is any errors that happen during the speech to text conversion, then we would execute the on error function. Cool. Now in the speech recognition setup and configuration setup, we first check whether the speech recognition API is being supported in your web browser or not. And then once we know that it's supported, we would instantiate the recognition object from the speech recognition API. And then we also instantiate the speech synthesis to have the voice feedback. Let's configure the recognition parameters here, where we say we want to access interim results and the language to be US, English. In the speech recognition event handlers, the first execution of onStart happens, where we simply update the is listening to be true, and then we are updating the visual components to say that it started listening. And in on end, we're going to set is listening to be false, and then if we have final transcript or interim transcript, we're going to call process voice command, which is the actual backend that we already have from Part-2, where it's going to convert the plain text into a JSON payload using the LLM. And then once those payload is being received, it's going to call the available endpoint to connect to the Google Calendar API and finally create the event. And in case of any error, we're just going to show that there is some speech recognition error. And finally, we get to the one that is actually processing this specific speech to text scenario in the onResult recognition.onResult function, where we are able to access to this event and we are able to retrieve the intermittent speech to text in real time. And we add it to the final transcript and interim transcript accordingly. And then we'll also show that in the UI so that the user has the visual of what exactly the text is being converted. So a quick TLDR, on start shows the visual that the listening is happening. In on result, we process the speech to text in real time. And finally, in the on end, we're going to call the process voice command with the converted text and call appropriate backend to process the NLP to retrieve the JSON payload and call appropriate API endpoint to complete creating Google Calendar event. Moving on to the fourth one, which I was referring before. This is the key integration point of our system where we connect the voice interface to our existing NLP pipeline from Part-2. Basically, the process voice command receives the converted text and it would call this specific endpoint, which takes care of using that plain text and LLM, which is Olama, to extract and structure a JSON payload and call Google Calendar API to create the calendar event. And once that's done, we're just going to show that in the UI that it's being created. And finally, we have voice feedback mechanism where we use the speech synthesis API, web speech API, to help us to have an audio feedback on the created event. So in the speech function, we're going to cancel if there is any ongoing speech that's happening. And then we're going to construct an utterance object where we configure the English language and the pace in which that specific audio has to give us the feedback. And we just call the speech synthesis with this specific utterance. Pretty straightforward, which is pretty awesome. As you can see here, after creating an event, you just like call this function with the desired text, and it works magically to have it to hear the audio feedback from there. This is the complete voice to action pipeline where we use the existing NLP pipeline infra and enable the users to initialize the speech from a typical plain point and enable users to initialize a plain natural speech and convert that magically to appear as a calendar event in their Google Calendar. You can test the voice interface by cloning this specific repository. It contains all possible code that is being demonstrated and follow the instructions to run and test and play around with it. This concludes the demo and walkthrough. In this tutorial, we have figured out how to use voice command capabilities to our calendar assistant, creating a hands-free way to schedule events. And I'll see you in the next one. See ya.